Good morning, everyone. Thank you for joining us today. Last time, we got a glimpse of how nanotechnology could really reshape our world for the better. But, with any powerful new tool, there's always another side to the story. So today, we're going to dig into the really big questions. Is it safe? Is it ethical? And who exactly is making the rules? To help us navigate all of this, we're joined by an expert in the field. Welcome.
Hello, everyone. Thank you for having me. It's a genuine pleasure to be here to discuss this important topic.
It's great to have you. All right, here's how we're going to break things down today. We're going to kick things off with the hard science, looking at the potential health and environmental risks. Then, we'll zoom out to tackle the huge ethical dilemmas this technology brings up for society. From there, we'll get into how governments are even trying to regulate all this. And we'll wrap up by talking about what it really takes to earn the public's trust. Okay, so let's jump right into it with those nanoscale unknowns. I mean, when we're talking about materials that are this unbelievably small, how do we even start to figure out if they're safe for us and for the planet? We've heard so much about the incredible, almost unbelievable promise of nanotechnology. So what's the crucial other side of that coin that we absolutely have to talk about?
Well, the other side of the coin is recognizing that the very same thing that makes nanomaterials so incredibly powerful is also what makes them potentially so risky. We just can't focus only on the amazing applications. We have an obligation to tackle the tough questions head-on. That means really digging into the health and environmental risks, the deep ethical dilemmas this technology creates, and the global rules we need to govern it all. And here's the thing, with nanoproducts already on store shelves, this isn't some abstract problem for the future. It's a challenge we have to face right now.
Right. That makes perfect sense. So let's start with safety. What is the absolute core concern when it comes to the potential health risks of these nanomaterials?
The central concern, the one that everything else stems from, is that nanomaterials can interact with our bodies and with the environment in ways their larger bulk counterparts just don't. We simply cannot assume that a substance that's perfectly safe in its normal form, think of something like silver or carbon, is automatically safe when you shrink it down to the nanoscale. Its fundamental behavior can change completely.
And this slide really illustrates exactly what I mean. If you look at the left, you've got your bulk material. It's predictable, we understand its properties based on its chemistry. But on the right, once you're at the nanoscale, it's a completely different ballgame. It's no longer just about what the material is, it's about the particle's size, its shape, its surface chemistry. All these things suddenly dictate how it behaves. And those new properties can lead to brand new, unpredictable biological interactions. That right there is the central puzzle for safety testing. So if the old safety rulebook doesn't really apply here, how do scientists even begin to study these new kinds of risks? I've heard there's a whole new field that's popped up for this. What exactly is nanotoxicology?
That's exactly right. A new type of risk demands a new type of science. Nanotoxicology is the field that's dedicated to understanding the really unique ways nanomaterials can affect our health, and it has to operate on a totally different set of principles than traditional toxicology.
The real difference here is the focus. Traditional toxicology, for the most part, looks at the dose, how much of a substance you're exposed to. But nanotoxicology says that for nanoparticles, that's just not enough information. A really tiny amount of a material that has a huge surface area, or maybe a specific needle-like shape, could be way more toxic than a much larger amount of that same material in a different form. So we have to look beyond just asking how much and start asking what kind. It's a whole paradigm shift. Okay, so if these particles can be more potent in different ways, how do they actually get into our bodies in the first place? What are the main ways we might be exposed? Researchers are really zeroing in on three main pathways. First is inhalation, which is a big concern for people working with nanopowders in manufacturing. Second is ingestion, which could come from things like food additives or water. And third is skin contact. But honestly, the real concern isn't just about them getting in, it's about where they might be able to go once they're inside the body. Yeah, the pathway really matters here. If you breathe them in, nanoparticles are so incredibly small they can travel deep into your lungs and from there potentially slip right into your bloodstream. If you eat or drink them, they could be in your food or leaching from packaging. And while healthy skin is a pretty good barrier, we're still not totally sure what happens with damaged or broken skin. But the biggest worry, the one you see there in step 4, is their potential to act like tiny little Trojan horses, to cross biological barriers that are there to protect our most sensitive organs, like the blood-brain barrier or the placental barrier that protects the developing fetus. That ability to get into places other materials just can't is a unique and very serious risk. Wow. Okay, so that's the human side. What about the environment? I mean, what happens when these engineered nanomaterials inevitably get out into our water and our soil?
That's the other major frontier of this research, a field often called nano-ecotoxicology. The key questions here really revolve around two things: persistence and accumulation. So, for example, a lot of athletic socks are treated with silver nanoparticles because they're antimicrobial. But when you wash those socks, where do those nanoparticles go? They wash down the drain and into our waterways. So, do they break down harmlessly, or do they persist in the environment for a really long time? And maybe most critically, can they get taken up by tiny organisms like algae and then bioaccumulate, becoming more and more concentrated as they move up the food chain from fish to birds and eventually maybe back to us? Researchers are working hard to understand the potential ripple effects on everything from soil microbes to aquatic life.
So, we've covered the potential physical risks, which are clearly significant. But the challenges definitely don't stop there. The second we start talking about using this technology inside the human body, we just rip open a whole new Pandora's box of massive ethical questions about what it even means to be human. So let's move beyond physical safety for a minute. The potential of nanomedicine seems to be creating this huge ethical crossroads. Can you break down this dilemma that people often frame as therapy versus enhancement?
Yes, this is easily one of the most profound ethical challenges nanotechnology puts on the table. On one hand, nanomedicine holds this incredible therapeutic promise. I mean, imagine developing nanobots that can hunt down and destroy cancer cells without harming any healthy tissue. That's clearly therapy. It's about restoring normal function. The dilemma pops up because the very same technologies could potentially be used not just to heal, but to enhance human capabilities, far beyond what we consider the typical norm.
And it is such a fine line. Therapy is all about fixing what's broken. Enhancement is about upgrading what already works just fine. So picture this: nano implants that could give us infrared vision, or nanobots that could supercharge our memory, or even therapies that could dramatically slow down the aging process itself. The tech that can heal could almost certainly be used to enhance, and that forces us to ask some very, very difficult questions as a society. That really does sound like something straight out of science fiction, but you're right, the potential is very real. So what kind of difficult social questions does that possibility, the possibility of human enhancement, really force us to confront?
Oh, it raises some of the most challenging questions you can imagine for a society. The most immediate risk is the potential to create a brand new and maybe even insurmountable form of social inequity. If these kinds of enhancements are expensive, and they almost certainly will be, we could literally see the emergence of a nano-enhanced class of humans with superior physical or cognitive abilities. This would just pour gasoline on the fire of existing social divides in a way we've never seen before. And it forces a deeper philosophical debate. Who gets to decide which enhancements are okay? Should we even be pursuing them at all? And what does it fundamentally mean to be human? What are the natural limits of a human life that we are willing to cross?
A world split between the enhanced and the unenhanced? That is a really sobering thought. Beyond that, what's the other major ethical minefield we need to be aware of here? I understand it has a lot to do with privacy.
Absolutely. The other massive issue is the potential for pervasive and nearly undetectable surveillance. The very same technology that lets us build these tiny medical bots also lets us build tiny sensors. And if those sensors become widespread, surveillance could become a constant, invisible part of our environment.
The concept that really crystallizes this fear is something called smart dust. And it's pretty much exactly what it sounds like. Just try to imagine swarms of autonomous sensors, each one no larger than a speck of dust, powered by vibrations or ambient light, just floating in the air all around us. You could scatter them through a city, an office building, even someone's home, and they would form this invisible, undetectable network. It's a really stark, tangible example of where this technology could potentially lead. And what could this dust do? Well, theoretically, it could listen in on our conversations by sensing the vibrations in the air. It could track our movements. It could even collect biological data, like our DNA from the skin cells we naturally shed, all without us ever knowing it was there. This completely redefines what we think of as surveillance, and it forces a really fundamental question. How do we possibly balance any potential security benefits against such a profound loss of personal privacy? Who controls this dust? Who owns the data it collects? And how could we ever hope to prevent it from being misused? So we're talking about health risks, a potential split in humanity, and the threat of totally invisible surveillance. The implications here are just staggering. Which brings us to a critical question. How are governments and international bodies even trying to get a handle on all of this? How do you regulate something like that? Okay, let's shift gears and talk about governance. Given all of these unique and, frankly, kind of scary challenges, how are regulators around the world even grappling with the task of overseeing nanotechnology?
They're really grappling with a fundamental definitional problem. The key question that they have to face is whether a nanomaterial should be treated as a new substance or if it's just an existing one in a new form. So, for example, is nanoscale carbon, like a carbon nanotube, the same substance as the graphite in your pencil? Chemically, they're identical, but their physical properties and their potential risks are worlds apart. How you answer that one question determines the entire regulatory path you follow, and different regions have come to very different conclusions.
That's a really fascinating distinction. Could you describe the different approaches that two of the major players, the European Union and the United States, have taken on this?
Yes, of course. They really represent two very distinct philosophies. Generally speaking, the European Union has opted for a more proactive and precautionary approach. The United States, on the other hand, has largely preferred to adapt its existing laws on more of a case-by-case basis.
And you can see these different philosophies laid out pretty clearly here. The EU, with its big REACH framework, is proactive. It essentially says a nanoform of a chemical is a brand new thing, and you, the manufacturer, have to prove it's safe before you can use it. This puts the burden of proof squarely on the company. In contrast, the US has tended to adapt its existing laws, dealing with nanoproducts on a case-by-case basis through agencies like the FDA and the EPA. This can mean a product might actually reach the market before all the specific nano-related risks have been fully assessed. The table also mentioned Canada's approach, which it calls pre-market assessment. Can you tell us a bit more about how that works in practice?
Of course. Canada's model is actually quite robust. It primarily uses its very powerful Canadian Environmental Protection Act, or CEPA. The key principle here is that any new substance, a category that automatically includes nanomaterials, is required to go through a mandatory and very thorough risk assessment before it can be manufactured or imported into the country. So companies can't just put a new nano product on the market. They first have to submit detailed safety data to both Health Canada and Environment Canada. It effectively puts that burden of proof on the innovator right from the very beginning.
That safety-first approach definitely seems like it's designed to build confidence. And that leads us perfectly into our final, and maybe the most crucial topic of all, public trust. Because at the end of the day, it doesn't matter how good the science is or how smart the regulations are, a technology simply can't succeed if people don't accept it. As you just said, public trust is absolutely essential. So how do public perception and, of course, the spread of misinformation present a unique challenge for the future of nanotechnology?
It's a massive challenge, truly. Because nanotechnology is still so new and complex for most people, public attitudes are incredibly easy to shape by how the media portrays it. And those portrayals often swing wildly between two extremes. On one hand, you see these utopian promises of miracle cures for every disease imaginable. And on the other, you get these dystopian fears of uncontrollable, world-ending technology. The field is also extremely susceptible to misinformation, both from companies making wild, unsubstantiated claims about their nano-consumer products and from fear-mongering about exaggerated risks. Bridging that huge gap with open, honest, and clear communication from the scientific community and from regulators is absolutely crucial.
This quote right here gets to the absolute heart of that dystopian side of the perception problem. The gray goo scenario is the classic fear, right? It's the idea of these runaway, self-replicating nanobots that just consume everything in their path to make more copies of themselves, eventually turning the entire planet into this lifeless, homogeneous goo. Now, while most scientists consider it a very remote science fiction possibility, it's an incredibly powerful image that perfectly captures the public's anxiety about losing control. And if we don't address these kinds of fears with transparent and realistic communication about what the real risks are and what safeguards are in place, we risk losing public trust entirely.
So, to try and bring all of these different threads together, could you summarize for us what you see as the key interconnected challenges we absolutely have to navigate to make sure nanotechnology develops responsibly?
Of course, and the key thing to remember is that these challenges are all linked. You can't really solve one without addressing the others. So, first, on a scientific level, we have to tackle the health and environmental risks through the rigorous science of nanotoxicology, always remembering that these unique nanoscale properties demand a cautious, evidence-based approach. Second, on a societal level, we have to engage in a broad, inclusive public conversation to confront the really profound ethical dilemmas, especially around human enhancement and privacy. And third, on a governance level, we have to keep building and refining clear, effective regulatory frameworks, adapting our laws to this new technology as our understanding of it evolves. Ultimately, the future of nanotechnology doesn't just hinge on our technical skill, but on our collective wisdom to manage it responsibly.
That is a perfect summary of the challenges we face. So, how do we actually move forward proactively? The source material brings up this idea of green nanotechnology. What is that all about?
Green nanotechnology is really a philosophy, and it's designed to do just that, to build trust and ensure sustainability right from the very start. It represents a commitment to making nanotechnology part of the environmental solution, not a new environmental problem. And it really has two main goals that work together.
The first goal, as you can see in step 1, is all about the application, using nanotechnology to create products and processes that are environmentally friendly. Think of things like much more efficient solar cells or better water purification filters that can remove tiny contaminants. The second goal, there in step 2, is about the technology itself. It's the idea of designing and manufacturing the actual nanomaterials in a way that is inherently sustainable. This means using less energy, avoiding toxic solvents during your production, and creating products that are designed from the get-go to be safe, effective, and ideally biodegradable at the end of their life. It's all about baking responsibility in from the lab bench all the way to disposal.
That's a fantastic note to end on. Designing responsibility right in from the very start. It really is clear that our wisdom in managing this technology has to keep pace with our ingenuity in creating it. Thank you so much for these incredible insights today.
It was my pleasure. Be sure to join us next time as we explore the future of nanotechnology to see what amazing breakthroughs might be just over the horizon.
To make sure you don't miss that episode or any of our other deep dives into the technologies that are shaping our world, be sure to subscribe to our channel, Tech, AI, and Beyond. Thanks for tuning in, and we'll see you next time.